Hey, welcome back to Deer Corner. Glad to see you back. I'm glad to be back. Took the month of January off. Went out and seen a few things. But today I want to discuss my power system here. And it's very, very simple, and why I went to it. When I started my planning to build this cabin up here, and I went through all the steps to make sure of what I was doing before I started my build. And one of my steps doing was to check on my power supply. At the time, I wasn't planning to go solar. I just wanted to come up, be able to flip a switch and do what I wanted to do. So when I went to the power company, and they came out on a Tuesday, and on a Thursday I got a quote, and the quote was $18,000 to run power up my driveway and up to here. So that was a big chunk of money. So I was thinking of other alternatives, and that's when I came up with solar. But at the time I was getting ready, solar was just taking off, and I just go through what I'd done and how I went through it. And one thing I can say is solar is not expensive. It can be expensive, but it don't need to be expensive. And I'm just going to go through and show you what I'm talking about. Now here, you have your typical solar setup. I have three 200-watt solar panels. I have a 30-amp controller. I have four 110-amp-hour deep cycle batteries, and I'll discuss this later on here. And it runs all to my 50-amp fuses, coming back from the batteries to 50-amp fuses, and I'll explain that too. But like I said earlier, I have a very simple system. I had to change this controller out. I had a top-of-the-line, good rated controller. When my gel batteries went bad, it ruined my controller, so I went back to another system. I got a 30-amp controller here. It's been working fine for the last year and a half. I have my solar coming in, my charging going out and down to my batteries. Then I'm coming up with my two leads from my batteries to my bars, and then I have my wiring bars which run to my fuses which run through the cabin. Very simple and very efficient. So one thing with this charger, if you can see it, you can tell that right now I'm charging my batteries 13.9, 14 volt. So I mean it's charging 13.9. My batteries are full, and you can go through and program it. Thing about this I can also have this on my phone to where I'm at work or at home and see what my controller is doing. Like my coffee. Once you've chosen your solar panels, one of the key things when you put in a solar panel, make sure you ground them. Make sure you run a ground wire. Even if you have portable panels that you take out, unfold, or take out and lay out, there are areas on them panels for ground wire, and that's for a reason. And a lot of people think, well, and I've read about it on Google and that, for lightning strikes or something like that, but that's not really the major reason. One of the major reasons is when wind goes across glass, it causes static electricity. And if you don't ground them, that static electricity builds up. And I have touched my panels and got popped. But they're grounded, and that was my fault because I didn't have an actual proper ground. Now they are properly grounded. But what happens is if you have two different sources of power in that panel, and in a way it's kind of like two magnets, different poles fighting each other, and your panels will not be as efficient. So it's a minute bit, it's not a whole lot of lossage, but still you want your panels to produce what you're thinking or you're wanting. Secondly, your angle. The angle of your panels and mounting them. I have a technique I found that I do. I change my angle 3 times a year, winter, summer, fall, and then reverse it. So my angle changes with the sun through the Alright, I hooked my meter up, I checked my wattage, my amperage. Right now I'm going to check my voltage, and make sure you hook it positive to positive, negative to negative on your panel wire, and turn it on the DC volt. And right now I'm at 22.5, 22.6, which is good. They've all been pretty close. 22.1 to 22.8, 22.5. So all my panels have been very close. Now I want to check my angle so that I could maximize my panels. So now by watching my meter, and once I find my sweet spot, what I call that's where it's going to go from 27, 26, 27, 26, right in there. Then what I'll do is I'll take my tape measure and measure down 25 inches. So what that is giving me is that the back has to be 25 inches higher than the front to maximize my voltage. Alright, these are my angles. I manually angle it and move it. This is my winter months, my late spring, my midsummer, and then I just reverse it. I go fall and back to winter, and that will change the tilt and the angle on my solar panels to maximize my panels. Yeah, your panels are, you have to do a little bit of engineering with them, but if you do it correctly, you can get more for less. Like myself, I have 3 200-watt panels, and by changing my angle, I get by with 3 panels. But if I made them stationary to where they stay in one angle all year, during the winter months, I would have to have a 4th panel because the days are shorter. But by able to change my angle, I get by with 3 panels, not 4, because I'm getting the efficiency out of my 3 panels. Now, starting off with my solar panels, I went with Eco-Worthy. Eco-Worthy, and the reason why I went with them is the price. They're very reasonably priced. The construction is very good for the price. Actually above, the construction of them are above the price of them. What I have read and checked on them, and which I have found out when I purchased my panels, I checked each one, and they were so very close in putting out the same voltage and the same wattage that you really couldn't tell a difference between them. Mounting them were great, wiring it up was great, and echo-worthy to me for the price. I didn't go wrong on choosing them panels. Now, the thing is, I could have went with a more expensive panel. And yes, I could have got more wattage, more amps, voltage, but I look at it as this way, is how much amperage I am going to consume in a day, and how much amperage I will put back in my battery pack in a day. So when you start looking at that in the numbers, you'll start figuring out that a big expensive solar panels really isn't economical, because yes, they put out more, but then when your battery banks are full, you're paying extra amount for a better, higher dollar panel that you're not going to be using. And for a good example, during the daytime here, while I'm here, I burn 85 amp hours a day average. When I have people over, we're watching TV at night and a lot more activity, I get up to 125 amp hours. And my 4 batteries, it'll give me 160 amp hours before I get into critical of usage. But in a day, my panels are putting out 8 to 12 amps per panel. And that is something else you have to get into, is your controller. And I'll get into that here in a little bit, and why I choose the controller I did. But anyway, I can charge my battery bank up in 6 hours and have enough through the day off my panels to run my cabin. So I'm running my cabin through the day and charging my batteries back up, and then I'm back at it again at night. So at the expense of panels, why would I want to pay the expensive panels more to where I'm not going to be using those panels for a period of time? And I'd rather pay for something and have it being used and not being used, if you get what I'm saying. So that's why I went with echo-worthy panels. One of the other things about them, when I went to check on ordering panels and getting them to my house, some of them were 3 weeks, some of them were back ordered, but with echo-worthy, they were there in 2 days. When I called them to check, because I went factory direct, they were very friendly. Well, back up a little bit. I sent an email to them, and they replied back to me within 8 hours. They answered my email, and that was very surprising. And then when I called and ordered my panels, but like I say, I only ordered 3 because I don't need more, and I'll get into that here in a little bit, but I didn't need more but 3. And they were still friendly enough to talk to me over 3 panels. So that tells me a whole lot about the company. And that's another subject people don't really understand. And if I'm a manufacturer and I've got thousands of parts, thousands of pieces out there, and a customer calls in and gets put on hold, or it takes 24, 36 hours to get a reply, a lot of people get upset about that. But you have to sit back and think. A company can't stay in business if they have to have thousands of people answering phones, and that's all they do. It's not economical. So when you call into a manufacturer and you're checking on them, keep in mind that you're not the only one. And yes, your good companies like EchoWorthy got back to me very, very quick. So that's just something else to think about. Now, controllers. I have a 30 amp controller. And a 30 amp controller is basically like this. When you're charging your batteries, a quick charge, what they call a quick charge, is actually damaging your batteries. A slower charge is better on your batteries, and your batteries have a better life. Now, I could go with a 50 amp. I could add on another panel and get 50 amps and do a quicker charge on my batteries, but it's damaging my batteries. And I'm not saving a whole lot. Basically, I'm saving 1 hour of charging with a 30 amp than a 50 amp. Now, there again, I'm using deep cycle batteries. I had a mistake. I had gel batteries. They were top of the line, and they had very high ratings. I started out with gel batteries, but the thing about them, they don't like cold weather. And a matter of fact, they would not take a charge. And one of them batteries actually had a short in it, and it damaged my controller. So here I went back to the drawing board and started over, and ended up with the system I got now. Now, I wired this cabin with 12 volt. I do not run any 110 volt through my walls. It's all 12 volt. And the reason I did that, I want to be able to control what power usage and where. And what I do is use converters, such for my TV. Now this is my 140 watt converter, and I'm converting my power in areas of my cabin from 12 volt to 110 volt. And I use this one here to power my TV and charge my laptop, charge my phone. And the reason I've done that is I can control what power usage I use by turning my converters on and off. So I'm able to control what areas of the cabin that I do need 110 volt by using converters such as this. But the rest of the cabin's 12 volt. Over behind the wood stove, if I want to use a vacuum cleaner or etc., or my microwave runs on a different converter that I can manually turn on and off without using power consumption. And the thing about DC, you have to use woven wire or copper woven wire. Now I wired this cabin with 10-aught wire, woven wire, but it is rated for 600 volt AC. Now this is how I ran my wiring. When I built the cabin, I used these channels to make sure my walls stay plumb vertically. And this is my wiring, and this is 10-aught wire, woven wire for DC current. But I went 10-aught, and it's rated for 600 volts AC. So if in the future I wanted to, I could run AC through the same wire that I'm running my DC current through now. And as earlier I'm going to show you, I just put a face plate over this for my switches and my lighting. With 10-aught wire, woven wire, but it is rated for 600 volt AC. And I went with the little extra expense of doing this. But if in the future something happened and I needed to go to 110, I could use the same wire to go to 110. And that's something else you need to look at when you're doing it. When you wire your panels, and from your panels to the building, always step it up a grade higher. Spend a little bit there, because in the future, if you did go larger, the expensive wire, you wouldn't have to change your wiring, and always step up a grade than what you're going to be using. That is another thing about wiring with solar. So this is the wiring I use, and it's working very well. Have no issues with it. Now my lighting is another system. These are what people call, or is called, door panel lights. These go into a Nissan driver and passenger door. And 3 of these that I have glued together is equal to a 600 watt standard light bulb. But they only burn 1.3 amps an hour. Now my lighting is such as what I explained earlier. And these are old outdoor lights that I found at a thrift store that I just put on my wall for interior lights. And they're equivalent to a 60 watt standard light bulb. But I'm only burning 1.2 amps an hour on them. So it is a huge saving, but I still get the light. That's what I'm recording on now, is the light given by these. Going to my 12 volt and using my 12 volt as a standard voltage here, I can maintain my power usage. And that is one of the key things, because people think solar, it's free, I can leave the light on and walk out, or I could do. No, you have to treat it just like a regular power bill, because it's going to go ahead and it's going to burn your savings, which is your battery bank. And that, if you have a rainy day the following day, you will find yourself without power. So my lighting I took care of, my wiring I took care of. Now my well is a 12 volt well pump, and it runs on pressure, but I manually put a switch on it too. And it's over in the kitchen area. And the reason I did that is so that it don't cycle, because all well pumps will end up cycling. And I don't want to use any voltage that I don't need to be using. So when I use the water, I turn the switch on. When I'm done using the water, I turn the switch off. So I can maintain power and my usage on my watering. So there's a whole lot to going solar or off-grid, but you have to do the math on your consumption. And I don't use a whole lot, but when visitors come over, or a couple hunting people that come over and deer hunt, and we use a little more, but I have a safety net, and I'm capable of putting it back the following day. Overcast, I still put back 15 amps. This winter during the ice storm, I was putting back 21 amps, even though the sun wasn't out. So you do put power back during a storm where people think you don't, you do. So solar to me was a lot of fun. It was a lot of fun to figure things out on what I could and could not use. and figure out the amperage. And it was a lot of fun. It was a challenge, but I got it now today to where I am, and like I'm saying right now, I charge my camera, my laptop, I could watch TV, I got lighting, I got heat, and my air conditioning. That's going to be another video on how I converted a 110 window air conditioner to 12 volt, and I run my air conditioning on 12 volt, and I'm going to do a video on that too. And there's a lot of fun. And the thing about it, you can build on it. The more your cabin or your place grows, the more you can build on your solar. But once you go 110 and you put in that panel, a 200 amp panel with all the breakers, and you wanted to build bigger, you're going to go through a whole lot of headache adding another panel, and etc., etc. But with solar, you can build very reasonable to get more. I'm glad you're with me. I hope to see you again. And go ahead and subscribe. And I hope a little bit of this information helped you out a little bit.